Imagine this. You're going about your day, checking your watch, and suddenly, time starts moving backwards. Clocks spin counterclockwise, your coffee spill rewinds into your cup, and yesterday's memories feel brand new. Sounds like a sci-fi movie, right? But what if first told you this actually happened, for 17 seconds, in a place scientists now call the time reversal zone? Buckle up, because we are diving into one of the most mind-bending cosmic anomalies ever recorded. This isn't just some abstract theory, it's a real event that challenges everything we thought we knew about time. Stick around, because you won't believe what caused it, and what it could mean for our understanding of the universe. The crew of the International Space Station, ISS, was conducting routine operations when they first noticed something amiss. It started with a minor glitch, a small discrepancy in the timing of their devices. At first, it was barely noticeable, just a fraction of a second here and there. But then, it became more pronounced. The clocks on their wristwatches, the timestamps on their digital logs, even the synchronized systems of the ISS itself began to drift out of sync. It was as if time itself was stuttering, refusing to march in the steady, predictable beat they were accustomed to. At first, the crew assumed it was a technical issue, perhaps a glitch in the ISS's complex computer systems. They ran diagnostics, checked their devices, and even recalibrated their instruments. But the problem persisted. The more they tried to correct it, the more erratic the timing became. It was as if their efforts to fix the issue were only making it worse. The crew began to exchange puzzled glances, their usual banter replaced by a sense of unease. This wasn't just a minor inconvenience, it was a full-blown anomaly, and it was happening across all their devices. The crew quickly realized that this wasn't a simple technical issue. They were dealing with something far more profound, a disruption in the very fabric of time. They documented the anomaly meticulously, noting the exact moments when their devices desynchronized. They observed that the discrepancy wasn't consistent. It varied, sometimes increasing, sometimes decreasing, as if the flow of time itself was fluctuating. The crew knew they were witnessing something extraordinary, something that defied their understanding of physics. They were no longer just astronauts on a routine mission. They were the first humans to encounter a cosmic anomaly, a moment when time itself seemed to be running backwards. In the heart of the time reversal zone, digital timers exhibited a peculiar and consistent behavior. They reversed for exactly 17 seconds. This phenomenon was not a fleeting glitch but a persistent and measurable event. Scientists observed that digital timers, which typically count up, would suddenly start counting down for precisely 17 seconds before resuming their normal upward progression. This behavior was not limited to a single device or type of timer. It occurred across various brands and models, suggesting a widespread and uniform effect. The consistency of this reversal was striking. Each instance lasted exactly 17 seconds, with no variation. This precision hinted at an underlying mechanism that was both precise and predictable. Researchers noted that the reversal was not accompanied by any other noticeable changes in the environment or the devices themselves. The timers would simply reverse, count down for 17 seconds, and then return to their normal operation. This consistency made the phenomenon easier to study, as it provided a clear and repeatable pattern to analyze. To understand the implications of this behavior, it's helpful to consider how digital timers work. These devices use a series of electrical pulses to keep track of time. Each pulse represents a fraction of a second, and the timer counts these pulses to display the current time. When a timer reverses, it means that the electrical pulses are being counted in the opposite direction. This reversal could be caused by a variety of factors, including electromagnetic interference or a temporary disruption in the flow of electricity. However, the exact cause of the 17-second reversal remains unknown. The impact of this phenomenon on daily life was minimal but intriguing. For most people, a 17-second reversal in a digital timer would go unnoticed. However, for those who relied on precise timing, such as scientists or engineers, this behavior could have significant implications. It highlighted the need for more robust and reliable timing devices, especially in environments where precision is critical. The time reversal zone served as a reminder of the complexities and mysteries that still exist in our understanding of time and technology. The time reversal zone presented some truly bizarre environmental anomalies, particularly when it came to the behavior of particles around the ship. Scientists observed that particles weren't moving as expected. Instead of flowing smoothly and predictably, they seemed to zigzag and dart around in erratic patterns. It was as if the particles were dancing to a rhythm that no one could hear, defying the usual rules of physics. This irregular velocity wasn't just a minor glitch. It was a significant deviation from what researchers had seen before. The particle speeds varied wildly, sometimes slowing down to a crawl and other times zipping around at incredible velocities. This chaotic behavior left scientists scratching their heads, trying to figure out what could be causing such unusual activity. Adding to the mystery were the reversed microimpacts. Normally, tiny particles collide with surfaces in a forward motion, leaving behind tiny marks or indentations. But in the time reversal zone, these impacts seemed to happen in reverse. It was as if the particles were not only moving backward in time but also leaving behind evidence of their reverse journey. This phenomenon was particularly puzzling because it challenged the fundamental understanding of cause and effect. If particles were indeed moving backward, it would imply that the laws of physics as we know them might not apply in this peculiar zone. The reversed microimpacts were a clear indication that something extraordinary was happening, something that defied conventional explanations. The irregular particle velocity and reversed microimpacts weren't just isolated incidents. They were part of a broader pattern of environmental anomalies that painted a picture of a place where the usual rules of the universe didn't apply. Scientists struggled to make sense of it all, collecting data and running experiments to understand the underlying mechanisms. The erratic behavior of particles suggested that the time reversal zone might be influenced by forces or fields that are not yet understood. These forces could be altering the trajectory and speed of particles in ways that are currently beyond our comprehension. The reversed microimpacts, on the other hand, hinted at the possibility of time itself behaving differently in this zone. It was as if the very fabric of reality was being stretched and twisted in ways that defied our current understanding of physics. In the heart of the time reversal zone, external sensors played a crucial role in detecting the anomaly. These instruments, designed to monitor and record data, began to exhibit peculiar behavior. One of the most striking observations was the appearance of negative timestamps on recorded frames. This meant that instead of the usual progression of time, the sensors were registering events as if they were happening before they should have. It was as if the clocks were running backwards, albeit for a very brief period. The negative timestamps were not random. They followed a specific pattern, with the most extreme case showing a reversal of 17 seconds. This was not a glitch or a malfunction. The sensors were highly sophisticated and had undergone rigorous testing. The negative timestamps were a genuine anomaly, a deviation from the expected behavior of time. Scientists were baffled. They had never encountered anything like this before. It was a challenge to their understanding of time and its unidirectional flow. To understand the significance of this, consider how we usually perceive time. We see it as a linear progression, from past to future. Events unfold in a sequence, and we can measure this sequence using clocks and other timekeeping devices. But in the time reversal zone, this sequence seemed to break down. The sensors were not just showing a delay or a pause. They were showing events happening out of order, with later events appearing to occur before earlier ones. It was a stark reminder that our understanding of time is not as complete as we might think. The implications of this anomaly are profound. If time can reverse, even for a brief moment, it challenges our fundamental assumptions about the nature of reality. It opens up new avenues for exploration and research. Scientists are now looking into the possibility of other such zones, where time behaves differently. They are also investigating the causes of this anomaly, hoping to uncover the underlying mechanisms. The negative timestamps on the recorded frames are not just a curiosity. They are a window into a world where time is not as straightforward as we thought. The crew aboard the spacecraft experienced a surreal and unsettling sequence of events. At first, it was subtle. Clocks ticked backward, but only for a fraction of a second. The crew members exchanged glances, their expressions a mix of puzzlement and amusement. They chuckled nervously, attributing it to a glitch. But then, the anomalies became more pronounced. Digital displays reversed, showing times from minutes to hours earlier. The crew's initial confusion began to deepen. One of the crew members, a seasoned engineer, tried to rationalize the situation. He suggested that it might be a malfunction in the ship systems. He started running diagnostics, his fingers flying over the control panel. But the systems seemed to be functioning perfectly. The engineer's confusion turned into a growing unease. He looked around at his colleagues, their faces now etched with concern. The laughter had stopped. The cabin was silent except for the hum of the spacecraft and the occasional beep of the instruments. The crew's fear escalated as the anomaly spread. Personal devices, like wristwatches and communication gadgets, also started behaving erratically. Messages sent just moments ago appeared to be received before they were sent. The crew members began to feel a creeping dread. They huddled together, their voices low and tense. Someone suggested contacting mission control, but their communications were garbled, as if they were receiving their own transmissions from the future. The crew's fear was palpable, their breaths shallow and hearts pounding. They were no longer just confused, they were terrified. The impossible was happening, and they were powerless to stop it. Delving into the archives of past space missions, scientists have found intriguing instances that might be related to the time reversal zone phenomenon. These old logs, scattered across various missions, reveal brief moments where similar anomalies occurred. For instance, during the Apollo missions, astronauts reported brief periods where their instruments behaved erratically. These moments were too short to be fully understood or studied at the time, but they share striking similarities with the 17-second reversal observed in the time reversal zone. One notable example comes from the Voyager missions. Engineers noticed that, for a few seconds, the spacecraft's chronometers showed a slight backward drift. This was dismissed as a glitch, but with the benefit of hindsight, it's hard not to see a connection. The data from these missions, though limited, provides a tantalizing clue that such anomalies might not be as rare as once thought. It suggests that the fabric of time might be more malleable than our current understanding allows. Another case comes from the International Space Station, ISS. Astronauts and ground control have reported brief instances where timekeeping devices showed irregularities. These were often attributed to cosmic radiation or electronic interference. However, the consistency of these reports across different missions and equipment raises questions. It's as if time itself is playing a subtle game, occasionally flickering out of sync with our expectations. These historical anomalies, though brief and often overlooked, offer a valuable starting point. They hint at a pattern that might be worth investigating further. By cross-referencing these old logs with modern data, scientists hope to uncover the underlying mechanisms at play. The more they learn, the closer they come to understanding the true nature of the time reversal zone and its implications for our understanding of time. Astrophysicists have been scratching their heads over the concept of time reversal, trying to understand what could possibly cause such a bizarre phenomenon. One of the most intriguing ideas revolves around exotic fields that might be lurking in the universe. These aren't your everyday magnetic or electric fields. Think of them more like invisible forces that could potentially mess with time itself. The idea is that these fields could create pockets where time doesn't flow forward as it usually does but instead runs backward. It's like having a cosmic rewind button. Some scientists propose that these exotic fields could be a byproduct of extreme gravitational forces or even dark matter interactions. Dark matter is that mysterious stuff that makes up about 27% of the universe but doesn't interact with light, making it invisible to telescopes. If dark matter has properties we don't yet understand, it might create localized zones where time behaves differently. Picture a tiny bubble in space where, for a brief moment, everything moves in reverse. Clocks would tick backward, and events would unfold in the wrong order. It's a mind-bending concept, but it's not entirely out of the realm of possibility. Another angle involves quantum mechanics, the branch of physics that deals with the tiniest particles in the universe. Quantum fields are all around us, influencing how particles behave. Some theorists suggest that under certain conditions, these quantum fields could flip, causing time to reverse locally. It's like a switch being flipped in the fabric of space-time. This idea is still highly speculative, but it's an exciting area of research. Scientists are exploring whether these exotic fields could leave any detectable signatures, like unusual patterns in cosmic radiation or anomalies in the behavior of particles. To test these theories, astrophysicists are looking for any hints of temporal inversion in the data they collect. They're analyzing cosmic events, particle collisions, and even the behavior of distant stars. The goal is to find any evidence that supports the existence of these exotic fields. If they can pinpoint a cause, it could revolutionize our understanding of time and the universe. Until then, the idea remains a fascinating puzzle, one that keeps scientists up at night, wondering what secrets the cosmos might still hold. The secrecy surrounding the aftermath of the time reversal zone incident is as intriguing as the anomaly itself. Mission logs, which are typically thorough and detailed, were partially redacted. This isn't unusual for sensitive missions, but the extent of the redactions raised eyebrows. Pages of data were blacked out, timelines were obscured, and some sections were entirely removed. The redactions weren't random, they were strategic, focusing on the 17 seconds when time seemed to reverse. This left scientists and enthusiasts alike to speculate about what was hidden and why. The crew, too, was instructed to avoid public statements. This isn't uncommon for classified missions, but the strictness of the instructions was notable. Crew members were briefed individually, emphasizing the importance of discretion. They were told to refer any media inquiries to official channels. Some crew members reported feeling a sense of unease, not because they were forbidden to speak, but because of the implied seriousness of the situation. It's not every day that astronauts are told to keep quiet about something they experienced firsthand. The lack of transparency led to a flurry of theories. Some suggested that the redactions hid evidence of a malfunction, perhaps a glitch in the spacecraft systems that caused the perceived time reversal. Others speculated that the crew had witnessed something extraordinary, something that challenged our understanding of physics. Without access to the full mission logs or the crew's first-hand accounts, it's difficult to separate fact from fiction. The secrecy only deepened the mystery, fueling both curiosity and concern. It's a reminder that in the vast expanse of space, there's still much we don't understand. All right, let's wrap this up. So, to sum it all up, we've been exploring this mind-bending phenomenon called the time reversal zone. Imagine a place where, for a brief 17 seconds, time decided to take a little detour and run backwards. It's like hitting rewind on the universe's remote control. Scientists are still scratching their heads, trying to figure out what caused this cosmic glitch. Was it a quirk of quantum mechanics, a ripple in the space-time fabric, or something even more mysterious? One thing's for sure, it's got us all wondering what else is out there, waiting to be discovered. Now, first know what you're thinking. How does this affect me? Well, think about it. If time can do a little backflip, what else can it do? Could there be other zones out there, waiting to be found? Maybe even places where time stands still or speeds up. It's enough to make you look at your watch and wonder, is it really ticking the way it should be? So, what's next? Well, we are not done exploring the mysteries of the universe. In our next video, we are diving into another cosmic conundrum that's sure to blow your mind. But for now, hit that like button if you're as fascinated by this as we are. And don't forget to subscribe so you won't miss our next adventure into the unknown. Until then, keep looking up at the stars and wondering what secrets they're hiding. Who knows? Maybe one day, you'll be the one to uncover the next big mystery. See you next time.